Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, Ricardo Lopes, and today I'm joined by Dr. Drew Bailey. He is Associate Professor in the School of Education at the University of California, Irvine. His research interests include mathematical development, individual differences, and longitudinal methods. And today we're going to talk about educational psychology. So, Dr. Bailey, welcome to the show. It's a pleasure to have you on.
Thanks, Ricardo. Yeah, nice to be here.
Okay, so when it comes to educational achievement, for example, I've already talked on the show with some behavioral geneticists, for example, who are some of the people that focus a lot on individual differences, and I know you're also interested in that in your work. So, to what extent do you consider the genetic basis of individual differences when it comes to educational achievement?
Yeah, good. That's a good question. So, like, to what extent do I consider, the behavior genetics research on educational attainment in my research? I guess I would say sometimes I consider it and sometimes I don't. So, I'll start with just what I think is a bad way or not a very useful way for me in my work to think about behavior genetics research, because maybe your audience will be familiar with some of these ideas. So I think that there's an overrated interpretation of findings from behavior genetics, which is that common environmental factors, so these are like environmental factors that make siblings more similar to each other, these factors seem to explain less variance in adult outcomes like cognitive skills or years of completed education than a combination of genetic factors and non-shared environmental factors that make siblings more different from each other. And these findings, I think, are pretty robust and can be observed from a variety of different methodologies. Sometimes the amount of shared environmental variance is pretty small, like for adult IQ scores, maybe like zero point 0.1 or zero point 0.2, or maybe zero point 0.3 for years of education, educational attainment. And so based on this information, some people have made the argument that therefore, like parents or the education system specifically, or public policy more generally, just don't matter in some sense. Mm-hmm. And of course, this is like a really politically charged topic, and lots of ink has been poured on both sides, with many social scientists questioning like some of the assumptions of these methods. My view is that the findings from behavior genetics are interesting, and I do think about them sometimes, but the relevance of this work for public policy is pretty indirect, okay? So it's not so simple that, 0.1, 0.2, 0.3, these numbers are small, therefore we should just give up. And the reason is, first of all, public policy researchers just don't care about variance explained for the most part, and they shouldn't. So if we're interested, let's say we're interested in the effect of a new cigarette tax, okay? We don't care how much variance the tax explains in smoking behavior. This is not like a question that would come up during our discussion about whether this new cigarette tax is a good idea. So we're interested in a more specific set of questions. So if we implemented an extra $1 or €1 tax on cigarettes, what would be the effect on changes in the rate of smoking or mortality or something like that, right? So how do we get from, so let's go back to the behavior genetics literature. How do we get from variance explained by common environmental factors to a different number that represents maybe like a more useful bound on how much we might expect some hypothetical social policy to change test scores or years of education. So in a twin model, like where you're comparing identical twins and fraternal twins, and you're using the extent to which identical twins are more similar than fraternal twins to make inferences about the extent of genetic influence, and the extent to which they're both quite similar to make inferences about the magnitude of common environmental influences in a twin model, the effect of like a one standard deviation change in common environmental stuff on the outcome of interest is actually just, it's the square root of the common environmental variance. Okay.
Mhm.
Uh, right. So it's the square root of R squared, right? It's R C squared. It's C. Okay, so remember those low pessimistic values of common environmental variance, like zero point 0.1 for IQ or, zero point 0.3 for years of education? Well, the square root of zero point 0.1, that's about zero point 0.3. The square root of zero point 0.3, that's like between zero point 0.5 and zero point 0.6. So that means that even if we assume that a social policy has to influence educational outcomes via common environmental factors. So not challenging the assumptions of the methods at all. I'm not going to talk about that right now. Even assuming that the model is right, a one standard deviation improvement in those factors, whatever they are, and common environmental factors, could generate maybe a third of a standard deviation improvement on IQ scores. That's like 5 IQ points, like half a standard deviation increase in years of schooling. I mean, those are really big effects, right?
Mhm.
So, in summary, like, it's not that this research is uninteresting or I don't think it's as fundamentally flawed as some people on the internet seem to think. I think it's interesting and important. Um, but basically, I agree. The economist James Heckman wrote in his critique of the book, The Bell Curve, that basically, as long as common environmental variance isn't really zero, then we should expect to see real influences of measurable environmental inputs on adult outcomes. And it turns out in some cases we do. And so, just by the way, for folks interested in this, I wrote about these ideas some in a book chapter with Jonathan Y on what intelligence researchers should and shouldn't expect public policy researchers to know or care about intelligence research.
Right. But I mean, in terms of the environmental educational interventions, could you give us some examples of those and perhaps tell us if they are really long lasting or not? Because, for example, when looking into specifically the literature on IQ and some environmental interventions on education that people have been trying throughout the decades, I mean, people, IQ researchers usually say that even if they raise IQ, it's only short term. So I mean, of course, I'm focusing on IQ here, and there could be other sorts of educational interventions and interventions to change other psychological traits that probably are important for in an educational context, like I don't know, conscientiousness or something like that. But what do you have to tell us about it?
Yeah, okay, great question. So, what interventions seem to have positive effects on adult outcomes? Um, so, uh, uh, what one good example is compulsory schooling. Okay, so there are several studies from labor economics that attempt to estimate the causal effect of an additional year of schooling on things like earnings. So I think the classic meta-analysis is by David Card, and they find positive effects on average. So to be clear, these studies, they're not just comparing people who stay in school for a year longer to a group of people in the same cohort who stay in school for a shorter amount of time, because obviously, right, those people are different on average for other reasons that could
Right.
plausibly influence later earnings. But they might compare, like, for example, the earnings of cohorts before and immediately after some new law requiring people to stay in school for an extra year um, before they can drop out goes into effect. And these estimates are a lot more trustworthy. And so education seems to influence earnings and also IQ scores in the long run. There's a nice meta-analysis on the IQ effects by Stuart Ritchie and Elliot Tucker-Drop. Um, so Uh, as to like other educational interventions that have long run impacts, it's interesting. Educational policy researchers don't care nearly as much about long run impacts on IQ as IQ researchers. Unsurprisingly, I guess, right? Um, so the examples that we talk about are often examples of interventions that seem to influence like things like years of schooling or criminal behavior or earnings, right? These are things that economists are much more interested in. We can talk more about IQ in a second, but I think these are important. So another intervention that seems to reliably affect long run outcomes is early childhood education programs, particularly for children from poor families who would not otherwise have received the early intervention. So there are several pretty good causal designs now at this point that estimate long-term effects of these kinds of programs, particularly on years of schooling. The evidence on long-term effects on IQ from those programs is much more mixed. Nutritional programs that target poor children. So in the US, we used to call our big program food stamps. Now we call it Supplemental Nutrition Assistance Program, SNAP. This also seems to yield long-run benefits that manifest on labor market outcomes, educational attainment. And I think these are more important really than adult IQ, right? Especially from a cost-benefit calculus, right? If should we be investing in these things? There are others: having a more effective teacher, going to a more effective school, broadly defined. And interestingly, I think maybe this could explain why you might be surprised based on your conversations with intelligence researchers, is that in some of these cases, impacts on achievement or aptitude test scores may decrease or fade all the way to zero, and the program yields impacts on years of schooling, earnings, or crime anyway.
Mm-hmm. Right. So, I don't know if this is right or not, but I guess that perhaps one of the reasons why intelligence researchers focus so much on the impact of educational interventions on IQ in the long run would be that perhaps IQ correlates really high with, for example, being able to attain higher levels of education, like higher education, college, university, and so on. I don't know if that's true or not. I don't know to what extent IQ is really so important in that way, but what do you think?
Well, so IQ does correlate with labor market outcomes and with educational attainment, and there are good reasons to think that part of these associations are causal. To the extent IQ is measuring real, skills that are useful, right, in the labor market. That's totally true, and that's a good reason to be interested in studying individual differences in cognitive skills. In my opinion, it's not a good reason to study them and to not be interested, right, in the long run, kinds of variables that we think that IQ is serving as a proxy for, right, in these kinds of studies, right? If we can actually get reasonably good measures of things like earnings and crime and attainment, then really, if you made me choose between looking at those and looking at IQ, maybe 10 years ago I would have cared more about IQ, but now I care a lot more about the real world, outcomes, right? That probably are more beneficial to individuals and society.
Right, right. When it comes to the fade out of educational interventions you mentioned, do you think there would be any way of trying to solve that issue?
Yeah, that's a really good question. So I don't want to leave listeners with the impression that that any attempt, right, at making kids' lives better or whatever is just going to magically translate into big impacts on these real world outcomes that we care so much about 10, 15, 20 years later. So despite these positive long run impacts I mentioned above, many of which uh, are long enough to justify increasing education-related spending substantially, it's also very common that impacts on targeted constructs get smaller and sometimes become statistically indistinguishable from zero after the end of treatment. So there are like dozens of possible reasons that contribute to this. So one is that although like in education, I think people do like a reasonably good job nowadays of targeting things that are important for kids to learn and at changing them effectively in the short term. I think something that's been underrated by educational interventionists and consumers of research about education is that kids are like exposed to a lot of educational input after the end of an effective educational intervention. So like let's talk about an example. So I have a kid who's 4, so like 4 and 5-year-old kids, if you tell them what's 2 plus 3 or something like that, they will often solve the problem this way. They won't just remember the answer, 5. They won't count in their head, 3, 4, 5. They won't even count on their fingers by saying 3, 4, 5. They'll just say, okay, 3 plus 2, 1, 2, 3, 4, 5. Right? It's pretty robust. The little kids will do this, quite reliably. And okay, so obviously, eventually we want these kids to just know the answer. We want them to know that's 5. It's going to help them a lot when they're doing, systems of equation problems in algebra. We don't want them, counting out all these problems on their fingers. And in the shorter term, before they memorize the answers, we want them to be able to understand. It's actually more efficient if you start with 3 and then count the smaller addend. Okay, that's much more efficient. So, if you never learn how to do this 3, 4, 5, you might not go on to more complex addition strategies. You might struggle to learn subtraction because learning 5 minus 2 is 3 is easier, presumably, if you know that 3 plus 2 equals 5. So presumably I could give a 5-year-old lots of extra practice at counting from the larger addend so they do this reliably. Okay, so this is an important skill. It's something we can change. Okay, so if I did this to 10 5-year-olds, would this fundamentally change these children's educational trajectories? And I think the answer is probably not. And the reason is actually, in some ways, it's good news. It's that in most like high-income countries, nearly all kids are going to learn to count from the higher addend in elementary school. So that means that the 5-year-olds are going to learn how to do this anyway. Okay, so unless in the meantime these 10 5-year-old kids who I teach to count from the higher addend are getting pushed really hard by me or someone else to learn the next skill in the progression and the next skill and the next skill. Or I'm teaching them to think about math in like this fundamentally different way than they did before, and also a different way than their first grade teacher and their second grade teacher is going to teach them to learn about it. It's hard to see how this intervention is likely to translate into extra years of schooling, or higher earnings, or lower crime. So one thing that I think is really important for people to consider when they're considering very specific targeted educational interventions is what else kids are getting at the same time, but also what they're going to get in the future if they don't, even if they don't get the intervention I'm promising to deliver.
Right. And since we're talking about interventions, let me ask you a broader question. Do you think that our education systems, and of course you probably focus mostly on the US education system, do you think that they should be reformed and how?
Yeah, good question. Well, we have different education systems, right? Education systems can vary a lot, just from even locally.
Yeah.
Um, so I don't really know. I've been thinking more about, how to improve the current system, by changing it at the margins. Although some potential changes at the margins, like adding on additional years of compulsory schooling at the beginning of kindergarten, or maybe a drastic overhaul of school funding systems, those changes would be quite major. I think all sorts of potential changes should be on the table. But there's a difficult problem, which is that the most dramatic overhauls will have the biggest potential to have large effects, large positive effects, large negative effects, right? Effects in either direction. But these big dramatic changes are also the changes for which we don't have a lot of good randomized controlled trials or natural experiments, because we don't have that many really big changes to the education system that happen over and over, that we can go back and study. So I don't think that's a reason we shouldn't discuss them, that they shouldn't be on the table completely. But the education system is a complex system with a lot of redundancies, and a lot of kind of hidden knowledge that's difficult for any specific person to know all of, if you're not embedded within the system, especially. So, I just think we should talk about these things, but we should be careful when we think about going forward with really dramatic change.
So I asked you about reformation, but do you think that there are any clear problems that at least we should think about?
Yeah, definitely. So one challenge is like a political challenge. So um, uh, educational investments, particularly early educational investments, these things don't pay off in terms of like increased attainment or reduced crime or something like that for a long time after you implement them. Okay, so if we give high quality free preschool services, higher quality, we invest $2,000 more per child or something like that, let's say, for the cohort who's currently 4 years old, right? They're not going to be at the point where we're going to know that they're going to have higher educational attainment for at least 12, 13, 14 years, right? Till they're around 18. So that means that the political group that makes the reform, they don't get credit for it, right? I mean, it's not like 14 years later, people notice, hey, that program seemed to work. Oh man, that guy who we voted out 12 years ago, we should really not have done that, or something like that. There aren't really a lot of examples like that I can think of. So there are several examples in the literature of educational policies actually that seem to have helped kids on net, like even in the long term, but were scrapped because they were politically unpopular in the short term. So like one example is like desegregating schools via busing within the US. So school districts that were completely segregated, or schools that were completely segregated, and then court orders would say, listen, you can't do this. You gotta integrate the schools. Okay, so you have to take some kids from the all white particularly from the all black district and part of the district, and bring them to the currently all white part of the district. So this policy is controversial actually among people of all sorts of political stripes within the U.S. nowadays. But some economists, including Rucker Johnson, have worked to suggest that actually when these black children grow up, it seems to help their labor market prospects, and it doesn't really hurt white children, right? So like this is a good example of a policy. It's like, how do we get back there? We probably don't, I mean, or if we do, it's going to be slow, difficult process. And the politicians who really put their political capital behind that are putting themselves on the line because there's going to be pushback. So what can we do to get around this problem? One thing I'm very interested in is, a really low cost solution is investing in forecasting. So like, I don't know, my colleagues and I have a paper where we survey like a bunch of education researchers on what do you think is going to happen to socioeconomic gaps on like broad broad achievement tests during the pandemic when a lot of children were having to learn remotely from home, right? Which was especially new and weird, especially for little kids, right? I mean, it's just weird to see kindergartners, sitting around and watching the screen and not sitting on the carpet, So anyway, we asked a bunch of researchers to make forecasts, and based on my read of the current evidence, our forecasts or our researchers' forecasts got the direction right. They predicted that poor kids would be gaps between socioeconomically advantaged and disadvantaged kids. Test scores would grow during the pandemic. So they got the direction right, as far as I can tell, based on the best evidence so far. And the magnitude of the estimate, they were pretty close, it seems. Maybe somewhere between maybe 1 and 2/10 of a standard deviation. It seems to be what I'm seeing so far. So a combination of like quantitative models that can make good forecasts about the effectiveness of various changes to the education system, combined with like aggregated forecasts from education researchers who can show a knack over time of making good forecasts. Some people are much better at this than others, right? At attending to the most relevant information. Some people kind of just throw out a number, right? Whatever feels right. That doesn't seem to be always a very good strategy. I could see this adding a lot of value, right? Because I think we're leaving a lot of knowledge on the table right now in education policy, and that we could do better. And maybe this kind of exercise could do something. It's not going to fully solve the political problem, but maybe it could do something to pass a little bit more of the blame on from the politicians responsible for implementing these kinds of policies to education researchers who really should be held accountable for the kinds of positions that they're advocating.
Right, I understand. So I would like now to talk a little bit about sex differences in education. But before I get into specific sex differences, I would like to ask you a general question. So to what extent do you think sex differences in different, for example, cognitive abilities really have an impact on education and educational attainment? Do you think that's really that important or not?
Yeah, well, as maybe you've gathered from debates around this stuff, it's kind of hard to figure out what's going on because for a few reasons. So for one reason is that people have very strong opinions about these things. But another is a scientific reason, is that it's just you have these different theories that make a lot of overlapping predictions. So like the group who thinks gender differences are socially constructed, they can point to dozens of ways in which gender differences are indeed socially constructed, right? It's not like there's a baseball gene or something like that, right? You got to learn the rules of baseball to play baseball, and professional baseball players are disproportionately male, but it's like part of that is definitely social constructionism. And then on the other hand, the sex differences drive gender gaps in occupational choices crowd. They argue that these like stereotypes and gender roles are downstream from, something like biological sex differences or something like that. But one reason that I'm doing less work in this area nowadays is that I've been frustrated some by, the ability of this group to produce really good mechanistic explanations of these things that are strong enough to satisfy like a reasonable skeptic. So like there's a version of this argument that there are like biological sex differences and then there's this complex causal chain that happens and then you get sex differences in occupational choices. There's a version of that argument that lots of social constructionists probably agree with, wherein you have gender differences and psychological constructs and occupational choices that are real, but they're downstream causally from a few sex differences that reliably develop in the absence of specific social input, like body size coupled with like gender segregated play. So like I think this is a version of what some people call like a biosocial model of gender development, which often like in arguments gets contrasted with like straw man versions of like a pure social constructionist or pure biological, version of the argument or whatever. Um, and yeah, so I just think part of the reason that folks are still having decades old debates in this area is that questions need to be posed much more specifically to have the potential for results to change people's minds. Right. So the question I think we want to answer is what kinds of or I don't know. I don't even know if both sides agree on the questions we want to ask. Well, one interesting question is what kinds of sex differences would you get, right, reliably in the absence of any sort of gender-specific socialization practices, right? And it's just really it's really hard to know. And we don't have a lot of good natural experiments like that because people pay a lot of attention to sex and gender, right? So, maybe a much more applied question that if one side can keep presenting evidence of social influences on gender differences in behavior as evidence that they're right and the other side's wrong, and the other side can keep presenting evidence that humans are in some ways a lot like other mammals, as evidence for their theory and evidence they're right and the other side is wrong, then people are just going to keep yelling past each other forever. We need to argue about more specific claims, like what would happen to the distribution of men in electrical engineering if the following three policies were adopted or something like that. I think, and arguing about those things would also have the advantage of also potentially being able to change or not change things, depending on what your goal is.
Right. But I mean, with all of that in mind, of course, I'm not trying here to get down to solving the debate between the more biologically slash evolutionarily minded people and the more social constructionistic minded people, let's say. But I mean, for example, there's this phenomenon that people have been calling the gender equality paradox, where it seems that by looking across different countries, some of them that score lower and other higher on gender equality, that we get this paradox where it seems that males and females, differ more in their occupational and educational choices in countries where we have higher gender equality than in the ones where we have lower gender equality. And the paradox there is because, from socially constructed view, let's say, we would expect the opposite. I mean, as gender equality goes up, those differences would shrink. So I'm talking specifically about that because I've read one of your studies where it seems that higher levels of gender equality show larger national sex differences in this case, mathematics anxiety and relatively lower parental mathematics valuation for girls. So, I mean, could you comment on this and specifically on that study and what you think generally about this paradox?
Definitely, sure, yeah. So that was a paper with Heisbert, Stute, Alex Moore, and my PhD advisor, Dave Geary, who I think you interviewed.
Yeah.
Yeah, um, you summarized the findings quite well. Uh, uh, Among countries that participated in PISA, which is this large international study of academic achievement and related constructs in high schoolers, within countries with higher levels of economic development and who scored higher on this gender equality index, there were also larger sex differences on a measure of math anxiety that was given to students in this study. So, like you said, I think the reason that people find this finding interesting is that it's inconsistent with this very simple story where like the only thing that determines how an individual feels about math, or at least the only thing that determines gender differences in these feelings, is some broad construct, gender equality or something like that. And to be fair to us, I think that there were some instances in the literature where people had made that kind of assertion, or that that it does follow from some theory of gender socialization that you should see more gender equal outcomes on psychological variables in more gender equal countries.
Mm-hmm.
But of course, in reality, it's not like we prove, right, that there's a causal effect of gender equality in the opposite direction, right?
Right.
So it's just that social dynamics are really complicated. So the correlation is pretty large in our sample across countries, about 0.6. But it's just a correlation, right? It's a stylized fact that needs to be explained. So it turns out, like you alluded to, that the pattern of larger sex differences in more gender equal countries seems to hold for several constructs and some occupation within some occupations, and has been called the gender equality paradox. And so one explanation that some people have proposed for this, the person I associate with this explanation is David Schmidt, is that in gender equal societies, men and women are free to express themselves more fully, their preferences, their deep preferences, and they're less constrained by social forces. And that's how you end up with larger gender differences in more gender equal societies. But the dynamics are pretty hard to nail down, I think. So you can make various gender equality paradoxes go away if you could, depending on what you control for in your model. So if you control for gender stereotypes, or by controlling for achievement and socioeconomic status. And of course, whether you want to control for these things depends on your mental model, or like what's really true about which of these variables are confounders that influence both gender equality and math anxiety or occupational choices, versus what's a mediator, right? They're caused by gender equality and subsequently influence occupational choices. And of course, those inferences cannot be drawn from the data alone, right? They require other kinds of knowledge. So it's really hard to know exactly what's going on. One potential contributor to the pattern is boys and girls' relative patterns of strengths. So some evidence so across all the PISA countries, it's much more of a regularity that girls outperform boys on the verbal test than that boys outperform girls on the math test. And there's some evidence from Herb Marsh's group that suggests that at least for older children, higher performance in one domain can actually decrease your self-perceived competence in the other domain. It's kind of cool, right? I mean, and I don't know, sad, I don't know, whatever, but it's interesting, right? That becoming better, at verbal skills, or being placed in a classroom where you're seen as one of the stronger verbal students, that because one of the ways that you form your identity about whether you're good at math or reading or something like that is via your self-perceived skill at the other domain relative to your peers. And so if girls consistently outperform boys on reading achievement across countries, one effect of that is that you can have girls actually with lower self-perceived competence on math skills than boys, and that effect can actually weirdly be bigger in places where uh, you know, the gender difference on reading skills is higher. Honestly, I don't know exactly what's going on. I'm not really doing much work in this area right now. I suspect that the most compelling account of what's going on will have to be able to explain between country differences in terms of within country processes. So it's not going to just be these country-wide scatter plots. We're going to have to figure out what's going on as things change within countries. There is some compelling evidence that within countries, math gender gaps favoring boys are larger in high socioeconomic status areas, and actually often even reversed in low socioeconomic status areas. There's a paper on that within the US written by, I think, Sean Reardon. Again, this is just another stylized fact, but at least it's a within country stylized fact. And maybe that's a good place to start as you're trying to figure this out. But in short, I think it's a lot more complicated than you change gender equality and then gender differences get bigger mechanistically. I think there's a lot more going on than that.
Yeah. So, I mean, but putting aside for a second the potential explanation for these differences and the gender equality paradox, there are certain differences, sex differences in cognitive ability that people bring to the table often that might have some influence on perhaps educational choices, educational attainment, and so on. So, for example, people mention, as you said, reading ability for girls, verbal ability more generally, and for boys, for example, spatial ability, the ability to, for example, rotate 3D objects in their minds, which supposedly would be influential when choosing areas like engineering and stuff like that. And I'm not sure if there are any significant sex differences in different mathematical domains or not. But are these differences replicable? Are they solid? And if so, do they really have a considerable impact in sex differences in educational attainment and choices?
Yeah, good question. So some of these, so within a particular population, uh, many of these differences are highly robust. Okay, so if you find that on the PISA assessment, girls outperform boys on a reading test at age 15. In 2015, you're probably gonna find the same thing in 2018, right? You have thousands and thousands of participants, right? So, uh, as to the question of maybe whether they are like universal truths or something, right? About like low level kind of processes that like differ between boys and girls. I'm less sure about that. I don't know exactly why girls are outperforming boys on these reading assessments so consistently across cultures, but there's a fair amount of variation across countries in the magnitudes of these gaps,
Mhm.
suggesting that they are at least somewhat sensitive to social inputs. Um, I'm sure some people would say, well, yeah, they're the the extent to which culture moderates these gaps reflects the extent to which some more fundamental biological thing is expressed or whatever. I don't know. It's hard for me to tell. Mental rotation within, as far as I can tell, within Western societies, that effect on 3D mental rotation is pretty big, and it replicates pretty well. Um, and I don't fully understand all the mechanisms where it comes from. We do have one paper with David Putz,
Mhm.
was the who maybe you also interviewed, was the first
Yes.
author. Find that circulating testosterone in the brain in one's body while they're taking the test, or fluctuations in testosterone across a short period of time do not seem to be at all related in men or women to mental rotation performance. So to the extent it's influenced by, excuse me, by biological stuff, it would probably be stuff that happens much earlier.
Right.
Um, so I don't know. I really am not completely sure. If I had to bet, I would bet a lot more uh, on occupational differences being strongly influenced by sex differences in interests. I think the weight of the evidence suggests that gender differences in occupational sorting are driven by lots of different things, but that occupational interests are a big part of it. Now, then we have to have the conversation, okay, where do gender differences in occupational interests come from? And I think they're just really determined by lots and lots of different complicated stuff. As you probably know, the gender roles, people will say, well, they're influenced by what kinds of people are currently in the job,
Mhm.
right? If tech is 90% male, then women will have lower interest in tech because they'll think this isn't for me, and the nature of the jobs will change so that they'll be more oriented towards what men like to do or what they find interesting or whatever. There's probably something to that, but then, as you know, the other side's going to say, "Yeah, but where did those differences come from in the first place?" And it's
Yeah.
all, you know, it's all. Um, so I don't know. I guess over the years, I tend to think that there's really something to all of these different positions. And so, like, the most interesting basic science questions are things like, you know, they involve these hypothetical thought experiments where, like, imagine that we treated men and women exactly the same, that we just are really hard to get at. Um, and then the most interesting applied questions are probably best answered with like experimentation, and then we don't have to have this culture wars argument all the time where men are really like this and women are really like that, or or everyone's exactly the same, or something like that. So yeah, it's probably a not the answer exactly you were looking for. It's definitely not like some of your other guests might answer, but that's how I currently feel about it.
No, I mean, that's perfectly fine, and this is an ongoing debate. And I mean, as you mentioned, at a certain point, it very easily turns into a sort of chicken and egg problem because, I mean, we have men and women fulfilling these sort of roles. Let's say we have these gender roles in society, and so I mean men and women are influenced by those roles, but then where do those roles come from? And then I mean, and it goes on and on and on, and it turns into a chicken and egg problem. So but I mean, just one last question. I mentioned mathematical ability. I mean, when it comes to the sex differences, I focused mostly on verbal ability and spatial abilities. But are there any significant sex differences in mathematical ability?
Yeah, that's a good question. There are several meta-analyses now on this, I think. And yeah, so it depends, I think, is the answer. Uh, but in interesting ways. So um, uh, as far as I can tell, you see bigger differences on narrower tasks than on like broader tasks, sometimes in predictable ways. Something when I was a graduate student, I was working on a big longitudinal study on children's math development in Dave Geary's lab, and we found moderate sex differences quite reliably on kind of speeded arithmetic tasks, right? And one could imagine that. In fact, a paper that of mine that I don't think it gets cited a ton or anything like that from when I was a grad student is kind of interesting here. Is in my opinion, I'm biased, that uh, boys were faster than girls. I think we had data from first grade to fifth grade or something like that. I should know this off the top of my head, but I don't remember. So boys were faster than girls every year at coming up with the answer to a speeded arithmetic problem. But boys were far less accurate than girls in the earliest year. I don't remember if it was kindergarten or first grade. Presumably because, and there's other evidence from other groups on this, that on average, boys are less uncomfortable, I guess, with the idea of shouting out an answer that might be wrong, right? Their threshold for speaking up seems to be lower, right? And it probably hurts them when they're quite young, right? But if you have that preference, right, for and wherever it comes from, I'm not saying that threshold is biologically primary, who knows, right? But if you have that sex difference, that it can have downstream implications for arithmetic. So we find that girls are a lot more accurate than boys in the first year of the study, but then it switches. So boys are still faster, and then eventually they become more accurate when they're forced to retrieve the problem really quickly. And so I think that's a good example. Again, I'm biased of a case in which you end up downstream with sex differences on speeded arithmetic, speed and accuracy, right? But one possible explanation for that is that you start with a more narrow sex difference, which is in like preference for being able to shout out the answer even when it's wrong, right? And that accumulates over time such that several years later you get sex differences in both. I think I guess if I were really going to dedicate the rest of my career to just trying to pick apart where these differences come from, that's kind of the method I would take, is like, what's the smallest number of initial differences that you need to end up with the pattern of complex differences that you get later on.
Yeah, that's really very interesting. So, just before we go, where can people find your work on the internet?
Sure, yeah. My website, I have a boring old academic website with links to all my papers. That's a good place to go. And I have a very boring academic Twitter account also that you can look at. But you might find neither very interesting.
Well, anyway, I will be leaving the links to that in the description box of the interview. And Dr. Bailey, thank you so much for taking the time to come on the show. It's been a pleasure to talk to you.
Thanks, Ricardo. I really appreciate it.
Hi guys, thank you for watching the interview until the end. If you like what I'm doing, please consider supporting the show. It's thanks to people like you that it keeps running. I will leave links in the description box to Patreon and PayPal. Any amount, even just $1 per month, would already be a great help. Otherwise, and if you like what I'm doing, please share the interview, leave a like and hit the subscription button. This show is brought to you by Enlights, learning and development done differently. Check their website at enlights.com. I would also like to give a huge thank you to my main patrons and PayPal supporters, Karen Litska, Anne Blanchett, Pererga Larsen, Lau Guerrero, Francis Ford, Hans Frederick Sunder, Ricardo Vladimiro, Craig Healy, Adam Kessel, Olaf Alex, Jonathan Wiesel, Jacob Klinkby, Matthew Whittingburg, Arno Wolf, Tim Hollacy, Enrique Alenia, John Connors, Paulina Barron, Philip Force Connolly, Jerry Mueller, Herbert Gintis, Rutger Voss, Bo Weingard, Rebecca Newberger Goldstein, Dan Demetriou, Robert Windiger, Rui Inácio, Arthur Coe, Zup, Marco Neves, Colin Holbrook, Susan Pinker, Bernardo Seixas, Pablo Santurbano, Simon Colombo, Jorge Espinha, Phil Kavanagh, Corey Clark, Mark Blythe, Roberto Inguanzo, Michael Stormir, Eric Neumann, Samuel Andreff, Tiago Nunes, Bernard Ugni, Alexander Dunbauer, Fergal Cusson, Evan Bodrenko, Al Herzog, Don Ross, Jonathan Librant, Oslan Bullitt, Nathan Nguyen, Stanton T, Samuel Correa, Eric Hines, Mark Smith, J.W., João Eira, Tom Hummel, David Sloan Wilson, Yacila Des Araújo, Eden Solon, Romain Roach, Dmitry Grigoriev, Diego Londonio Correa, Tom Roth, Yannick Punter, Adana Rusmani, Charlotte Bliss, Nicole Barbaro, Adam Hunt, Pavel Ostazewski, Nelek Bach, Catherine and Patrick Tobin, Al Ortiz, Guy Madison, Gary G. Hellman, João Linhares, Lida Cosmidi, Sam Afzal, Adrian Yegi, Nick Golden, Paulo Tolentino, João Barbosa, Jules Price, Edward Hall, Edin Bronner, Franca Bortolotti, Gabriel Pons Cortez, Ursula Litske, my producers Isar Webb, Jim Frank, Lucas Staffini, Kian Gilligan, Luís Caetano, Tom Vanagdam, Curtis Dixon, João Linhares, Benedict Mueller, Vega Guidi, Sardas France, and Thomas Trumbull, and my executive producers Michel Rugieski, Rosie, James Pratt, Matthew Lavender, Sergio Quadriano, and Bogdan Kanivets. Thank you for all.